Welcome to the second video for Pre-Calculus Trig, Section 2.3. We're going to do some example problems using inverse trig functions. So now, with inverse trig functions, we have a way to find unknown angles. So if we know sides, now we can find angles. So the input is a side ratio. So 4/5 in this example is a side ratio, and your output is the associated angle. So if you have an angle of 36.87, then you have a side ratio of 4/5. So inverse trig functions have restricted ranges so that they're one-to-one functions, and we talked about that in the first video. This means that the angle that you find, your answer essentially, must be within the allowable range. So that brings those circles that we had at the end. Let me show you those. These right here, this is what I'm talking about. Your answer to any one of these functions must fall on this side of the unit circle between -π/2 and π/2. And your answers to any one of these functions, those angles must be between 0 and π. So in this example here, it says solve the right triangle knowing two legs. So one of the legs, A, is 18, and the other leg is 23. So when we say solve the right triangle, that means we want all 6 pieces of information. So I generally make a chart. So here's my chart. So I put my 3 known pieces of information on there, and I'm going to find the last 3 pieces of information. So we can find small c, the length of hypotenuse, by using Pythagorean theorem. So 18 squared plus 23 squared is equal to c squared. So in my calculator, I get 853 is equal to c squared. So now to find c, I'm just going to take the square root. So that's c is equal to 29.2062. I'm just going to keep that amount of those digits because depending on what your homework problem says, as far as what rounding digit to go to, it just depends on how it's worded. All right, so I'm just going to keep all 4 of those digits right now. All right, so I've got C. Now, normally, on the other problems we've done, we could subtract one of the acute angles from 90 to find the other one, but we don't know any of the acute angles on this. So here's where your inverse trig functions are going to come in. So if I want to find the angle A, from that perspective, 18 is my opposite side, and 23 is my adjacent side. So I can say the tangent of A is equal to 18/23. So if I want to find A, I would say the inverse tangent of the tangent of A, and that'll allow me to just have A is equal to the inverse tangent of 18/23. So I could type the inverse tangent of 18/23 into my calculator, and I'm going to set my mode to degrees so that it'll return me degrees. So I got 38.047 degrees. So that's angle A, 38.047 degrees. So now that I have one of the acute angles, I can subtract that from 90, or some of you like to say 180 minus 90. So that would be angle B, 180 minus 90 minus 38.047. So you could do it that way, or you can just say B is equal to 90 minus 38.047. And that'll give you your angle. So I'm getting, on my calculator, 51.953 degrees. All right, so now we have everything. We've solved our our right triangle. So we said 51.953. We have all 6 pieces of information. All right, in example 2, it says solve the right triangle. This time we know one leg and the hypotenuse. So A is equal to 4 and C is equal to 6. So we want to find B. So using Pythagorean theorem, we can say B squared is equal to C squared minus A squared. So that's B squared is equal to 6 squared minus 4 squared. So B squared is equal to 36 minus 16, which is equal to 20. So B is equal to the square root of 20. So this one we can reduce by branching out here and saying B is equal to 2 on the outside, 5 on the inside, 2 root 5. So we'll just say 2 root 5. So that's an exact number, whereas a decimal approximation, you would have to retain some digits to the right of the decimal place. Next, let's find either angle A or angle B, so you can start with either one. So let's say I'm going to look for angle A, so that means from that perspective, this is my opposite side, and 6 would always be your hypotenuse. So I could say that so that's opposite and hypotenuse, that would be sine. So the sine of A is equal to 4 over 6. So then I could say the inverse sine of the sine of A, which would allow me to find A, is equal to the inverse sine of 4 over 6. So what you do to the left, you do to the right. Inverse sine undoes sine because they're inverse functions. So typing that into my calculator, I'm going to do it in degree mode. I get 41.8103 degrees. So I'm going to write that up here, 41.8103 degrees. So I'm just not rounding that any further at this point. All right, so then to find angle B, I can say angle B is equal to 90 minus 41.8103 degrees. So I got 48.1897, and I wrote it in my chart. So now I have all 6 pieces for my right triangle. I solved my right triangle. So here's another triangle problem. So we haven't really gotten into anything having to do with the circular trig angles yet, so we're still talking about just side lengths and angles within acute triangles. So here your information is given to you in the form of a trig function. So if we're told that the tangent of theta is equal to this side, root 5, divided by this side, 6, that means that root 5 must be my opposite side, and 6 must be my adjacent side. So it doesn't matter whether you call this acute angle theta or this acute angle theta. So I'm just going to arbitrarily put my theta here. What matters is where you put your side ratios relative to the angle you're talking about. So that means my opposite, root 5, would have to go here, and my adjacent 6 would have to go here. All right, so that means I don't know this side over here, my hypotenuse, so I need to find out what that side is. All right, so I could say that c squared, using the Pythagorean theorem, is equal to root 5 squared plus 6 squared. So c squared is equal to 5 plus 36. That's equal to 41. So c is equal to the square root of 41. So we have this side over here now is the square root of 41. All right, so now let's see. If we put it in chart form, we can call this A, this B, this C, which would mean this would be B, and this would be A, and this would be C. So we can go ahead and put it in chart form just to make everything very clear. So we've got A, B, C. So there's my chart. So, whoops, I have two B's. Okay, so that's supposed to be an A. All right, so now let's go ahead and find either angle A or angle B. So let's just go ahead, since we have that arrow drawn, let's go ahead and find angle B over here. So that means opposite is here and adjacent is here. All right, so I could say tangent of the angle B is equal to root 5 divided by 6. So then I could say the inverse tangent of the tangent of B, so I can cross those out, is equal to the inverse tangent of root 5 over 6. And that'll give me B. So if in mode is equal to degrees in my calculator, I'm going to type in the inverse tangent of the square root of 5 over 6. And I'm getting 20.439 degrees. So that's my angle B. All right, so now the last thing that I can do then is I can say angle A is equal to 90 minus 20.439 degrees, and that'll give me angle A. So I got 69.561 degrees. All right, and let me just mention that if you felt like it, you could use inverse trig functions to find both of those angles, either way, or you can find one and then subtract from 90 to find the other acute angle. All right, so we solved that problem, finding angles using inverse trig functions. So in this example, it says evaluate the inverse sine, this should say range here, over its range, negative pi over 2 to pi over 2. So I've drawn my circle showing where that range of values is that we could use for our angles, for our answers basically to the inverse sine function. So our answers have to fall on that side of the unit circle. So these are your negative angles between 0 and negative pi over 2. And these are your positive angles between 0 and pi over 2. So this first one says the inverse sine of root 3 over 2. So the value of sine is your input, and we want to find the angle. So we have to figure out where on the circle the value of the sine is root 3 over 2. So right here, at this angle pi over 3, the value of the sine is root 3 over 2. So that's my answer, pi over 3. Next, it says, what is the inverse sine of negative 1/2? So where is the sine negative 1/2 is what we got to find out. So the sine is negative in this quadrant, the fourth quadrant. So negative 1/2 would be here, and that's at negative pi over 6. All right, so I'm not going to call that angle 11 pi over 6 because I have to be between negative pi over 2 and pi over 2. I'm going to call it negative pi over 6. So my answer would be negative pi over 6. All right, the next one says the inverse sine of 0. So if my sine is 0, what angle does that correspond to in this area over here? So the sine of 0 is 0 right here at 0 degrees. So that answer would be 0 degrees or 0 radians. All right, so then on this one here, it says the inverse sine of negative 1. So we want to figure out where is the sine negative 1. Well, the sine is negative 1 down here at negative pi over 2. So I'm not going to call it 3 pi over 2. I'm going to call it negative pi over 2. Because I have to be within this range, negative pi over 2 to pi over 2, because that way inverse sine is 1 to 1. All right, so the inverse sine of negative 0.26. So that's like a quarter. So that's halfway in between here somewhere. So we've got an angle in here. So we can either do it in degrees or radians, depending on what your question asks you. So let's just do it in degrees. So if you put your mode in degrees on your calculator, you're going to type in second function inverse sine. On the old handheld, it's the second function. So in your Desmos, you would go into your function list and pick the inverse sine. So the inverse sine of negative 0.26. So if you want radians out, you put it in radian mode. If you want degrees out, you put it in degree mode. So in radian and degree mode, I got negative 15.07 degrees. So that's about right here. All right, so at that angle right there, the value of my sine is negative 0.26. So these are negative angles. These are positive angles. All right, next one, F says the inverse sine of the cosine of pi. All right, so the cosine of pi, we have to write this out as a number. Let's look at it this way. The cosine of pi is over here, and the cosine of pi is negative 1. So this is the inverse sine of negative 1. So that means where is the, so we did that one up here, the inverse sine of negative 1, and we found out that the sine is negative 1 at negative pi over 2. All right, so then we've got the inverse sine of a number tangent of pi over 4. All right, so pi over 4 is here. So the tangent is 1 for that 45, 45, 90 triangle. Remember, if your sine and your cosine are the same value, your tangent is 1. So that's the inverse sine of 1. So that means which angle has a sine of 1? Well, the sine is 1 at pi over 2. So this one is pi over 2. Okay, so H says, what is the inverse sine of the cosine of pi over 3? So let's find a number for the cosine of 2 pi over 3. So that would be over here. So the cosine of that number is negative 1/2. So the inverse sine of negative 1/2, that means we're looking for the angle whose sine is negative 1/2. All right, so negative 1/2, we're back over here, this angle again. So that is negative pi over 6. So we have one more to do here. So this says the sine, the inverse sine of the tangent of pi. All right, so pi is over here. So if the tangent of pi, so the tangent is the sine. So let's write this out. So this is negative 1 cosine and 0 sine. So the tangent is sine over cosine. So that is 0 over negative 1. So this would be the inverse sine of 0. So that means, what is the angle whose sine is 0? All right, so we know that one too. That was this angle over here. The sine is 0 at 0 degrees or 0 radians. All right, so we utilized our circle over here to solve these inverse sine problems. Okay, now we're going to try something similar. This time we're talking about evaluating the inverse cosine function. So the answers have to fall between 0 and pi this time. That's the range of answers for the inverse cosine function. So we're asked find the inverse cosine of negative root 3 over 2. So we need to find out the angle that has this cosine, negative root 3 over 2. So if I think about that, that's going to be that's going to be over here. All right, so at this point right here, my cosine is negative root 3 over 2. So that means that would be the angle, let's see, that's 5 pi over 6. All right, so this angle is 5 pi over 6. All right, so B says the inverse cosine of root 2 over 2. All right, so that's over here, right here. So the cosine is root 2 over 2 at pi over 4. So my answer is pi over 4. All right, C says find the inverse cosine of 0. So that means my cosine is 0. My cosine of 0 is right here at pi over 2. So the angle who has a cosine of 0 is pi over 2. Okay, so notice I'm not choosing I'm not choosing this angle down here because that's in the restricted range. Okay, so I've got to choose this one here, pi over 2, and not 3 pi over 2. All right, D says the inverse cosine of 1. So the angle whose cosine is 1. All right, so that would be 0 over here. 0. All right, this one says the inverse cosine of 0.8. So we want the angle whose cosine is 0.8. So we can either do it in degrees or radians. So let's go ahead and do it in radians this time. So I got 0.644 radians. 0.644 radians. So this is radians here. And you could do degrees or radians. So if you're doing degrees, that would be 36.87 degrees. All right, so that's somewhere around here. Okay. So either way, you can either do it in radians or in degrees, depending on what you're working in. All right, so F says, what is the inverse cosine of the sine of pi over 4? So we need a number. Let's find a number for the sine of pi over 4 so we can understand what's going on here. So the sine of pi over 4 is root 2 over 2. So you could put that in just like it's written here, but the reason I'm drawing this out as a number so we can draw the parallel between what we're doing here and what we're doing here. All right, so I've already done this problem here before. The inverse cosine of root 2 over 2 is the angle pi over 4. All right. Okay, so this one says the inverse cosine of the cosine of 4 pi over 3. So the cosine of 4 pi over 3, so let's just draw that on here. So this would be 3/3. So this would be 4/3 down here. So the cosine of 4 pi over 3, so this would be negative 1/2 cosine and negative root 3 over 2 sine. So we're talking about the inverse cosine of negative 1/2. Okay, so we haven't done that one yet. Negative 1/2. So the cosine is negative 1/2. So that would be over here. So let's see, that angle right here is 2 pi over 3. So the cosine is negative 1/2 at 2 pi over 3. So 2 pi over 3 is my answer. And it's within the range there. Okay, so the last one of these says the inverse cosine of the tangent of pi over 3. So we want the tangent of pi over 3. So this is the inverse cosine of some number, which is the tangent of pi over 3. All right, so pi over 3 is right here. So that would be cosine 1/2. sine root 3 over 2. So the tangent is going to be root 3 over 2 divided by 1/2. So that means I could cancel the 2's out, and I'll get root 3. So we're talking about the angle whose cosine is root 3. So I've got the inverse cosine of root 3. So root 3 is not one of our standard cosines on the unit circle, so we're going to have to use the calculator for this. So we could either do it in degrees or in radians, or we could do it in both. So before I do this, I want to find out what the decimal value of root 3 is so I can see whether it's between -1 and 1, because if it's not, then it's going to be does not exist. So the root 3 is 1.732. All right, so that's greater than 1. So we're going to conclude that the inverse cosine of the tangent of pi over 3 does not exist, because all values have to be between -1 and 1 when we're talking about input to the inverse cosine function. So if you get something out of that domain, let me just write the domain down here, then your answer is does not exist. Okay, another way that we say does not exist is undefined. So these functions, these inverse cosine functions, are not defined outside of the domain -1 to 1. Okay, so if you've got an input number here that's not within this domain, -1 to 1, you're going to say undefined. So if you tried to type that into the calculator, it would reply undefined. So for example 6, we're talking about the inverse tangent over its range, -pi over 2 to pi over 2. Means the angles that we come up with as our answers must be between -pi over 2 and pi over 2. Now the domain for your inverse tangent function is not restricted to -1 to +1. So the domain is all real numbers for the inverse tangent function. Okay, so the first one says inverse tangent of 0. So we're looking for the angle whose tangent is 0. So the tangents are a little more complicated, because if you think about tangents, you know that tangents are quotient functions where you've got a sine and a cosine involved in creating the tangent. So if the tangent is 0, like it is here, that means the numerator, the sine, must be 0. So the only angle within this side of the circle here who has a sine of 0 is actually the 0 degrees or 0 radians. So I'm going to say 0 is my answer here. Because the next one says the inverse tangent of 1. So we're trying to find the angle whose tangent is 1. Okay, so we know from our study of the unit circle that occurs at pi over 4, where your cosine and your sine are equal to root 2 over 2. They have the same magnitude, so sine over cosine would give you 1. So this one is pi over 4. So we're talking about this angle here, pi over 4. The next one says inverse tangent of root 3. So if we're talking about a quotient once again, and we're left with root 3 being the result of this quotient, you might remember that if we take root 3 over 2 and divide it by 1/2, the 2's cancel, and you're left with root 3. So if we can find the angle whose sine is root 3 over 2 and whose cosine is 1/2, and that both of them are either both positive or both negative, of course, we don't have any other choice for them to be both positive, because in this quadrant, the only other option would be positive and negative. All right, so that means we need to find the angle in the first quadrant who has a sine of root 3 over 2 and a cosine of 1/2. All right, so if you have your unit circle out, or if you don't have it memorized, that's this angle right here, pi over 3. So the answer to this one is pi over 3. Now, looking at D, we have the other result. Sometimes on the unit circle on your special angles, you'll get the root 3 in the top and sometimes in the bottom. Now, what we've got here, if you'll recall, is just the rationalized form of 1 over root 3, where the root 3 is in the bottom. Just to refresh, if you rationalize 1 over root 3, you would get root 3 over 3. Okay, but I have a negative here, so that means either my sine or my cosine is going to have to be negative. So that means I'm going to be in the fourth quadrant. So in the fourth quadrant, in order to get root 3 in the bottom, that means my sine would have to be 1/2 and my cosine would have to be root 3 over 2, so that my 2's cancel this time and my root 3 ends up in the bottom. So my sine has to be 1/2 and my cosine has to be root 3 over 2. All right, and I have two different sines, so that has to occur in the fourth quadrant. All right, so that would mean, so I said sine was 1/2. Whoops. Let's get rid of those. Sine is going to be 1/2 at this pi over 6, so it would be negative pi over 6. All right, so at that angle, your sine is negative 1/2 and your cosine is positive root 3 over 2. Okay, so that'll give you a tangent of negative 1 over root 3, and rationalizing the denominator, you'll get negative root 3 over root 3. So the result of this is that my inverse tangent of that negative root 3 over 3, I'm going to say, is negative pi over 6. Okay, so E says the inverse tangent of the cosine of 0. So that means I want a number for the cosine of 0. So the cosine of 0, 0 being this angle here, is 1. So that means if I have a tangent of 1, what is my angle? So we did that one already. That one was pi over 4, where the sine and the cosine have equivalent magnitudes and the same sign. So this is going to be pi over 4. So we have one more. So we have the inverse tangent of the sine of pi over 2. So here's pi over 2. So the sine of pi over 2 is 1. So this is the inverse tangent of 1 again, which is pi over 4. So notice that all of the angles that we got as answers lie between negative pi over 2 and pi over 2, which is our restricted range for the inverse tan function. So on this problem, what we're doing is we're evaluating sine, cosine of tangent at the angles which are defined by an inverse trig function. All right, so in the first one, the inverse cosine of 0 is the angle who has a cosine value equal to 0. All right, so I'm going to go down here and I'm going to use this one here for the inverse cosine, my allowable angles. So if I want to find the cosine value of 0, the cosine is 0, that means I would have to be up here at pi over 2 where the cosine is 0. So the cosine is 0 at the angle pi over 2. So I'm going to say this is really the sine of pi over 2. And we know the sine of pi over 2 is 1. All right, so on the second one, we've got the cosine of the angle whose sine is root 3 over 2. So that puts me up on this one here. So positive root 3 over 2 for your sine value. All right, so positive root 3 over 2 for your sine value would put you up here at the angle pi over 3. So this is really the cosine of pi over 3. And we know the cosine of pi over 3 is 1/2. So once again, if you don't have your unit circle memorized, go ahead and pull that out and follow along with me on your unit circle, pausing the video whenever you need to locate an angle. All right, so this one says the tangent of the inverse tangent of 1. So this problem is saying the tangent of the inverse tangent of 1. So that means the tangent of the angle whose tangent is 1. So that's pi over 4 within negative pi over 2, which is the one we're going to use for inverse tangent. So that means the tangent of pi over 4 is what we're looking for here. So that's 1. So basically these two invert one another and we're left with 1. All right, so on this one it says find the tangent of the angle whose cosine is 1/2. So we're dealing with the inverse cosine, so we're down here on this picture. So if my cosine is positive 1/2, that means I'm up here at pi over 3. All right, so I'm taking the tangent of pi over 3. So this is the tangent of pi over 3. So if I'm at pi over 3, that means my cosine is 1/2 and my sine is root 3 over 2. So sine over cosine is going to be root 3. The 2's are going to cancel. On the next one, it says the tangent of the inverse tangent of 9. All right, so basically the only thing we need to do here is figure out whether 9 is within the domain of the inverse tangent function. So in your notes, we have the domain of the inverse tangent function is negative infinity to positive infinity, or all real numbers. So that means 9 is within the domain of the inverse tangent function. So we can just say the tangent is the inverse of the inverse tangent. The tangent and the inverse tangent, a better way to put it is they undo each other. So the answer would just be 9 in this case, because the tangent undoes the inverse tangent because they're inverses of each other. So now looking at F, I'm finding the sine of the angle whose cosine is 2.5. The problem is the domain of the inverse cosine function is negative 1 to 1. So that 2.5 is outside of the domain of the inverse cosine function. So this is undefined, or you might say does not exist. And then we have one more to look at here. This says the cosine of the inverse sine of 6, which means the cosine of the angle whose sine is 6. Well, once again, we have the problem that the domain of the sine function is negative 1 to positive 1. 6 is not within that domain, so the inverse sine of 6 is an undefined function. So we're going to have to say this is also undefined or does not exist, because 6 is not in the domain of the inverse sine function, which literally means that there's no value of the sine which is outside that negative 1, 1 range. Okay, now these are triangle problems here, because you're taking the cosine of an angle, so we're looking for a side ratio, and here you're taking a sine of an angle. Remember, inverse trig functions give you angles, so we're looking for a side ratio. So we've got these two side lengths given in terms of an inverse tangent function. So I just drew a general triangle, and let's just randomly say this is our acute angle theta that we're talking about. So that means the angle theta has a tangent of 5 over 12. So that means this would be 5 over here and 12 here. So opposite over adjacent. All right, so that means if I wanted to find the cosine of that angle theta, I could use those two known side numbers, but I need the hypotenuse number here. So I could find that by just saying c squared is equal to 5 squared plus 12 squared. So that's 25 plus 144, which is 169. So square root of 169 is 13. So this is 13 here. So the cosine of that angle theta is just going to be adjacent over your hypotenuse. So that's going to be the cosine of theta is equal to 12 over 13. So that's what we're looking for, 12 over 13. So part B says we want the sine of the angle whose tangent is 5/12. So we're talking about the same angle input here, the angle whose tangent is 5/12. So that's this angle right here, whatever it is. All right, so the sine of that angle is going to equal to your opposite over your hypotenuse. All right, since we figured out those side lengths already, we're going to say 5 this time. That's your opposite side over 13. So this is your sine, and that's what we're looking for. All right, so these are right triangle problems here that you're given these side lengths to work with. So let's try another problem like this. So what we're asked is find the cosine of an angle where the angle is defined by the angle who has a tangent of 1/7. All right, so if I draw a generic triangle here, and let's just randomly say this is my acute angle theta. So the tangent is 1/7, so this is my opposite side over here. So that's your 1, and your adjacent side is 7. All right, so if I want to find the cosine of that angle whose tangent is 1/7, I need to find my hypotenuse again. So that means c squared is equal to 1 squared plus 7 squared. So that's 1 plus 49, that's 50. So c is equal to the square root of 50. So c is equal to, so 50 is 5 times 10, which is 5 times 2. So that's 5√2. So this side length over here is 5√2. All right? So that means if I want to find the cosine of theta, all right, so this is theta, the angle whose tangent is 1/7, then I need the adjacent over the hypotenuse. So that's going to equal 7 divided by 5√2. All right, so I need to rationalize my, let's move this out of the way here. I need to rationalize my denominator here. So that's 7√2 over 5 times 2, which is 10. All right, so that's the cosine of the angle theta whose tangent is 1/7. All right, in part B, I'm asked to find the sine of the angle whose tangent is 1/7. So that's the sine of theta. So that's equal to my opposite over my hypotenuse. So my opposite is 1, and my hypotenuse is 5√2. So I'll rationalize that denominator, and I'll get √2 over 5 times 2, which is 10. So my sine of the angle whose tangent is 1/7 is √2 over 10. So we're going to do one more example here. So this first problem says find the inverse cosine of the cosine of 14 pi over 3. So first let's find the cosine of 14 pi over 3. So here's my unit circle over here. So let's draw our third line so we can count 14 pi over 3. So I've divided the unit circle into sectors of pi over 3. So let's go ahead and count in the positive direction 14 pi over 3. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So right here I'm at 14 pi over 3. Right? So that puts me on the 2 pi over 3 line, basically. So my cosine is negative 1/2. My sine is root 3 over 2. So I'm looking for the inverse cosine of negative 1/2. All right, so that's negative. So now let's look at the range of values for inverse cosine. So for inverse cosine, you can be anywhere between 0 and pi, but you can't use these angles down here. All right, so the inverse cosine, of course, is defined between 0 and pi for our range. All right, so that means, of course, we're at right here. So this is 2 pi over 3. So right there, at that angle, we've got a cosine of negative 1/2. So 2 pi over 3 is the answer. That's the inverse cosine of the cosine of 14 pi over 3. All right, so let's look at B now. So this time, I'm evaluating the inverse cosine of the cosine of 5 pi over 4. So let's find the cosine of 5 pi over 4 first. So I've highlighted the pi over 4 lines, and let's count 5 of them. So that's 1, 2, 3, 4, 5. So I'm right here. So I've got a negative root 2 over 2 as my cosine, and a negative root 2 over 2 is my sine. So we're interested in the cosine of 5 pi over 4. So we say negative root 2 over 2. All right, so then we go ahead and look at our allowable range of values for the inverse cosine. And I'm between 0 and pi again, and I can't use these angles down here. So that means if I want to have the same cosine, I'm going to have to go up here where the cosine of 3 pi over 4 is the same. So I could just draw this line here and show you the cosine, which is the x value, is the same for 3 pi over 4. And we know that. That's also negative root 2 over 2. So my answer here is going to be 3 pi over 4. That angle has the same cosine as 5 pi over 4, but it's in the allowable range of the inverse cosine function. So on C, we're asked to find the inverse sine of the sine of 25 pi over 6. So let's count by 6's. So this would be 6, 12, 18, 24, 25. So I'm right here at pi over 6. So that means I've got a cosine of root 3 over 2 and a sine of 1/2. So I'm going to find the inverse sine of the sine of 25 pi over 6, so that's 1/2. So if I look at where I can be if I'm an inverse sine, I can be between negative pi over 2 and pi over 2, but I can't be over here. All right, so that means this angle we said was pi over 6 is okay to use here. So we can say this is pi over 6. All right, so the angle pi over 6 is between negative pi over 2 and pi over 2. And its sine value is 1/2. Resume problem D. We're taking the inverse sine of the sine of 13 pi over 4. So I've got my fourth lines drawn. So let's count by 4. So I've got 4, 8, 12, 13. So I'm over here, and so that means my cosine is negative root 2 over 2, and my sine is negative root 2 over 2. So I'm going to say I've got the inverse sine. So the sine of 13 pi over 4 is negative root 2 over 2. All right, so now let's look at where we can be. Let's go down a little bit. So if you're evaluating an inverse sine, I can't be over here. I've got to be between negative pi over 2 and pi over 2. So I'm on that side. So on that side of the circle, if I'm looking for a negative sine, I've got to be here at that 45-degree line. All right, between negative pi over 2 and pi over 2, I've got to call that negative pi over 4. All right, so that's what I'm going to call that. I'm not going to call it 7 pi over 4 because that's not between negative pi over 2 and pi over 2. So I've got to call it a negative angle. So this is negative pi over 4. So of course that is coterminal with 7 pi over 4, but this is what I need to call it in order to be within that range, negative pi over 2 and pi over 2. So this is all of the example problems we're going to do for section 2.3. So you should be ready to go ahead and attempt your homework problems. Let me know if you have any questions.